last year's exam, this question pretty much caused Twitter to break, with people making some fairly unkind comment about Hannah and her sweets. But it's basically combining algebra with a probability tree. So we're only interested in her eating 2 orange sweets, and we know that there are n sweets in a bag. So if you imagine the part of the probability tree that's orange and orange, when she takes the first sweet, there are n in the bag, of which 6 are orange. Now, if she's eaten one of the orange sweets, there's now n minus 1 sweets in the bag, and only 5 of them are orange. And we know that if we multiply along those branches, 6 over n times 5 over n minus 1. So the
first thing that we need to do is to multiply these brackets on this side. So 6 times 5 gives me 30, and n times n minus 1 gives me n squared minus n, and that all equals 1 over 3. Now then I can cross multiply these, so I'm going to do 3 times 30 and 1 times n squared minus n, so that's going to give me 90 equals n squared minus n, which is already looking a bit like the question. And if I move this 90 over and subtract it, you should see that n squared minus n minus 90 now equals 0. The second part of the question asks you to solve that. It is a quadratic equation, non-calculator paper, it will factorise. So it does equal 0. I'm looking for numbers that multiply to make minus 90 and add to make what would be minus 1. So those numbers are going to be minus 10 and a plus 9. Now when I solve these two equations, because either n minus 10 equals 0 or n plus 9 equals 0, this will give me an n value of 10 or of minus 9. Now given this is the number of sweets in a bag, you can't have minus 9 sweets in the bag, so n is 10. Question 21, it's a vectors question and it's not that easy, but basically you need to be looking at the vectors that you can work out. So we're told that m and d are midpoints. No, we're not. We're told that b and m are midpoints, and then this is a third of the way along there. Now we're asked to prove that AMD is a straight line, so this would be coming down from here. That means that first of all we need to find the vector from A to M and then the vector from M to D. Now we don't know these lines here, but what we can do, because we're told that because B is the midpoint of AC, we know that this is also A. So we're going to find the routes that we can. So for example, we know that BM, or the M is halfway from B to E. So one of the things we could do is find our way from B to E, and then we can halve that and use that to find our way from A to M. So to go from B to E, I'm going to go, so this is what I'm looking for, I'm going to go from B to C and from C to E. B to C is going to be minus A, C to E is going to be minus 3B. So that is B to E. That means to go from B to M, I just need half of that. So BM is going to be minus a half A minus 1.5 B. And if I want to go from A to M, I'm just going to do A to B, which is minus A, and then from B to M, which is minus half an A minus 1.5 B. And when I simplify that, I get minus 1.5 A minus 1.5 B. So my next step is to work out the bit that goes from M to D.
and of course I now know how to go from M to E because it's half of BE. So I just need to find some way to fit this in. So M to D is going to be M to E plus E to D. So M to E is the same as B to M, so it's going to be minus a half A minus 1.5 B, and E to D is just a plus B. Now when I simplify this, I'm going to be left with a minus half A and a minus half B. Now if you look at these two vectors, you can factorise both of these so that this one is minus 1.5 A plus B, and this one is minus a half A plus B. That means that they are multiples of each other, and they share a common point, so they share point M, and that means they are therefore on a straight line. Okay, so for this question you basically need to prove that the two vectors A to M and M to D are multiples of each other, and then because they share point M, they are on a straight line.